And Mark, I don't know anything about you or your background except that it's gray. And I'm looking forward to. I'm sorry, I'm getting pretty punchy, but I'm going to hand it over to you.
Thank you very much, Bob. All right. Just for everyone who is tuned in, my name is Mark Pesci. 30 years ago, I founded the first consumer virtual reality company in the world, a company called Ono Sendai. Yes, named after the company in Gibson. Yes, we got his permission. Our mission was to create the first consumer VR system. Now, this when the average processor was chugging along at about 8 megahertz. We made really good progress. We actually solved some of the fundamental hardware issues around tracking the body in space when we were contacted by a small company called Sega. They were actually the biggest video game company in the world at that point because they were going to make a Sega Virtua VR system. I helped design that system. Now, that system never saw the light of day because no matter how good your senses are, trying to run a virtual reality system on an 8 megahertz 68,000 is not going to give you the kind of performance that will prevent kids from getting sick when they put the head mount on. So, we had a solution 30 years ago, but it wasn't quite ready. I went from there to start doing my own research work. This was when something called the World Wide Web was just starting to happen. I took some of the work that I had been thinking about at Ono Sendai around creating networked virtual spaces, what we would call the metaverse today, and then applied those to the World Wide Web. And with my friend Tony Parisi, co-invented VRML, the virtual reality modeling language, which is essentially the 1.0 specification for the metaverse. It became a standard, it became part of MPEG-4, it became an ISO standard, and for, several years during the mid-1990s, that was the new shiny thing in virtual reality. Now, gone on to do many other things since then. If you're interested, you can take a look. My bio URL is down there on the screen. You can take a look at what I've done. What I want to do now is talk through some of the ideas from my latest book. My latest book is called Augmented Reality, Unboxing Tech's Next Big Thing. And I actually opened the book with a bit of an example from history, something that happened to us here in Sydney. I live in Sydney, Australia. And so I got to see something happen quite close up. And it turns out that when Niantic was preparing to release Pokemon Go, and Pokemon Go is in a lot of ways the archetypal example of augmented reality. When they were preparing to release it, they wanted to sort of beta test the servers to see if they could handle the strain. And so Australia, very luckily, got Pokemon Go about 72 hours before absolutely everyone else in the world. And it was a very magical time because it was just on the weekend in Sydney. And all of a sudden, it seemed like all of the young people everywhere were gathered in little groups, all of them looking at their smartphones, all of them hunting Pokemon. And it turns out that Niantic knew something about Sydney because they'd used Sydney as a backdrop in their earlier augmented reality game called Ingress. And so everything they'd learned from Ingress actually fed into the map of the world that they used for Pokemon Go. One very specific location is a place called Peg Patterson Park. Now, this park is about 10 kilometers outside Sydney. It's in a very nice residential suburb. There's basically tall apartment blocks all around. The park is not very big. It's really just a little postage stamp of a park. It's a place where you let the kids play on the swings, maybe take the dog for a walk. It's not, beautiful, but it's very functional. And again, as I say, it is surrounded by all of these apartment buildings. Now, this park had been used in Ingress as one of the locations where they would play the capture the flag game. So as soon as Niantic used that map for Pokemon Go, they put a Pokestop here. And that seems very innocent, right? We know about this place. We know we can put something here. We'll put a Pokestop here. Let me tell you what happened next. So this is now, you think about it, it's released on Friday in Australia. This is now Tuesday, the 16th of July, 2016. Now keep in mind that is the dead of winter here in Sydney. All right, so here's what happened. A few young people came by and found that there was a Pokestop at this park. And they're like, oh my God, this is great, there's a Pokestop. And then they probably messaged a few friends saying, hey, we found a Pokestop. Now, this park is also quite close to a subway station. So basically you can take the subway to Rhodes and then walk about 2 minutes and then you're at Peg Patterson Park. And all of a sudden, what happened was a few more people would come, they would message a few friends, and then a few more people would come, and then one of those friends would actually drop a lure. They'd spend $1, they'd drop a lure, all these great Pokemon would come in, everyone text their friends, oh my god, there's this park you have to come to, it's really easy to get. And you can see how this produces a positive feedback loop. And then by 11:30 p.m. on Tuesday, the 16th of July, you have about 1,000 young people in this tiny little park in the middle of Sydney. And they're not rioting, they're not causing any trouble, they're backed up with Ubers and taxi cabs because at this point the train system's actually probably shutting down for the evening. But this park is also now surrounded by apartment buildings with people trying to sleep because it's 11:30 on a weeknight. And some of these people got so angry, they actually started to drop water balloons on the folks down on the ground. Just basically, go away. We're trying to get sleep here. We don't care. We're trying to play their game. Eventually, the police had to come and, quote unquote, break it up. It wasn't a riot. It didn't really need to be broken up. But the thing that I learned very clearly from this particular moment in this particular technology, the thing that I took away was that Niantic was able to change the behavior of people in particular space by inscribing something in that space. And this is a general thing. What we saw happen over and over and over again is that, in fact, people would use the fact that they were inscribing space in Pokemon Go. You're writing a creature in space, you're putting a Pokestop there, and when you do that, you change the behavior of people in that space. And this was the penny drop moment around that, was when Pokemon Go was introduced. And this shows you right up front the incredible potency of augmented reality to be able to change the behavior of people in space by changing the information they're being presented to operate on in that space. All right, let's go to a really basic question here. What is augmented reality? Because we have a lot of different definitions floating around. Some of those definitions have channeled into a very specific idea of what augmented reality is. I want to take that idea and basically blow it apart. Now, the roots of augmented reality indisputably lie in a paper that was written by Ivan Sutherland in 1965. If you haven't heard of Ivan Sutherland, pretty much everything you're doing comes from Ivan Sutherland's work. In 1963, he invented Sketchpad, which was basically the first human computer interface of note. You know, anytime you touch a screen or use a mouse to touch a screen, you are copying the work that he invented in Sketchpad. And then, between 65 and 68, he worked on what he called the ultimate display, a display that tracked your head so that the display could be wherever you were looking. And in order to do this, he eventually had to come up with an armature. Now, this is the final version called a head-mounted display because it is literally the first head-mounted display from 1968. He has this armature going up, which is tracking you mechanically, thus giving this device its nickname, the Sword of Damocles. Now, people see this and think this is the first virtual reality system. It is not. It is the first augmented reality system because the entire system was designed with half-silver mirrors so that it is projecting simultaneously what the computer is showing you and what's in the real world. So in other words, the computer image is overlaying the real world. Something else I need to point out was to make this work, Ivan Sutherland had to teach the computer how to draw 3D graphics in real time. So Ivan Sutherland invented augmented reality, invented virtual reality, he invented interactive computing, and he also invented real-time three-dimensional computer graphics. All right, so they all come together in this 1968 evocation of a head-mounted display. And it all worked, but it was all very hard. It all took a long time for us to get to where we think we are now. This is where we think we are now. These are the Snap kind of still experimental AR goggles. We know that Facebook is working very hard on them. Microsoft has the HoloLens, which has gone very well since 2016. They're very big and bulky. We know that Apple is definitely working on them, although Apple will never say anything about it. But everyone thinks that this is what augmented reality is, that it's a set of spectacles that you put on. That's not what augmented reality is. That is a display system for augmented reality, but that is not what augmented reality is. Augmented reality is a lot more straightforward, a lot more simple to explain than a particular device. There are two basic operations that are associated with augmented reality. The first is attaching metadata to a place. In other words, here's a Pokestop, here's a Pokemon. Here's another player in the game. Who knows what it could be, all right? But in the cases of Pokemon Go, you can see how those pieces of metadata can be situated by Niantic for the purpose of playing a game. And then the second operation is the converse of that, which is rendering that locative metadata. And this is where we get the image of the spectacles, because what the spectacles are doing is they're rendering, they're making visible that data. But the spectacles themselves, those are not augmented reality. They are used for augmented reality. But the essence of augmented reality is attaching locative metadata to place. And that is not a new thing. In fact, you can look back basically all the way to everyone that we would consider human, and you will see instances of humans attaching metadata to place. You know, you have all of the cave drawings, not just in Europe. We have cave drawings in Australia that are attested at 55,000 years old, the oldest art that we know of. And what do? They tell us stories about the people in those places, the kinds of animals, and the kinds of environment. In other words, they were attaching metadata which told them about the space that they were in, so that they, their children, their grandchildren, time out of mind, would have those markers. And of course, that's the antique version, the prehistoric version. When you get to the historic version, well, you know, you can walk through any major city and you'll see plaques on all sorts of buildings that add metadata to the building that is not present just by looking at the building. When was this building built? Well, this is a plaque celebrating the 100th anniversary of this building being built. And it's not only telling you who built the building, but it's also telling you who put the plaque there, because apparently they deserve some credit too. So we have this idea of putting metadata in space as being a new thing. It's an augmented reality thing. Well, actually, we have been augmenting reality for as long as we have been human. All right, what we need to do now is we need to start taking a critical look at how people are having us think about augmented reality. And I think we really need to start at the top. So say hello to Mark Zuckerberg.
Let's talk about art. Now, with augmented reality, you're going to be able to create and discover all kinds of new art around your city. So, this is a piece at Facebook headquarters. And, without augmented reality, this actually just looks like a blank wall. But when you are in augmented reality, you get this beautiful piece of art that's not just a painting on the wall, but it fills up the whole space. And it's 3D, and not only that, it's something that would be impossible to build or make in reality, because you have this infinite waterfall of paint coming down, and it's really quite something to look at. Now, one thing that's kind of a funny side effect of this is that now around Facebook, we notice that there are just people gathering around looking at blank walls. So, this is going to be a thing in the future, right? I mean, it's just people just kind of sitting around and staring at blank walls. So we actually put a physical plaque on this wall to commemorate that we think this is going to be one of the first pieces of augmented reality street art in the world, but there's a lot more like this coming.
I mean, it's really a little ironic to sit here and think about the fact that they actually added physical metadata because they'd already added augmented reality metadata to that wall. It's interesting. And I remember when I saw this talk in 2017, I thought, okay, that's very cute and that's very funny. And this was, I think, before Facebook had really been caught out for leaning into accelerating division. And so it was very possible to look at all of this and go, oh, this is all going to be wonderful. We're going to put art up everywhere. I looked at this, and I looked at this much more skeptically. I'm like, okay, if you can write anything you want anywhere you want, which is essentially the power that's being attested to by Mark Zuckerberg using augmented reality and using the Facebook augmented reality tools. You can go into a cafe and you can scribble something on the wall for your friends to read, or leave a note for your girlfriend on the fridge, or put art on the wall. All of these seem very nice. They seem very good, but you really do. Whenever you're talking about social spaces and social actors, you actually have to go to the worst possible case. And so let's say that you have this power and this power is freely distributed. Augmented reality like that is available everywhere on all smartphones and on your spectacles. And then someone walks up to the Grand Synagogue in Sydney. Now, if I am one of the people who is charged with taking care of the Grand Synagogue in Sydney, am I going to let arbitrary people leave arbitrary messages on that building? No. No, I'm absolutely not. I'm going to protect that building because those are the kinds of buildings that get defaced, that become the subject of hate crimes. And so we have this idea that it's just going to be this completely new, wonderful, angelic realm of human behavior and human communication, and we completely put aside the fact that it rarely works out that way, and even when it does, it only does temporarily. And so we come to the first of the major AR dilemmas, which is the right to write. Who gets to decide who gets to write whatever they want, wherever they want in augmented reality? This is an issue that is not a technical issue. It is relatively easy to do this technically. There are any number of apps that you can download on any of the app stores that will give you this power. But giving you the power does not give you the right. It seems like that actually falls more into a legal and social penumbra. And this is exactly the point that we start to see popping up around Pokemon Go, because people were playing Pokemon Go in all sorts of places they shouldn't have. And in fact, Niantic changed Pokemon Go's map so that Peg Patterson Park was no longer a Pokestop because the people at Peg Patterson Park were tired of getting a crowd every night of people playing Pokemon Go. And Niantic has been sued by a number of municipalities for basically changing the rules in the spaces of those municipalities by putting features there, by asserting a right to write that these municipalities say does not exist. And in fact, Niantic has settled all of these cases out of court because the last thing they want is to get precedent made. But there will be precedent made and there will be law, because the right to write, again, not a technology question, it's a legal question. All right, the second dilemma that we have to confront is that by design, by its essential feature of operation, augmented reality is a technology of networked surveillance. And I think this is made very clear when you take a look at Facebook's Project Aria rollout. This was a device that was introduced last year that was going to be a testbed for the technologies that they will be using in their augmented reality spectacles. We're just going to take a look at a portion of that specification where it talks about the sensors that are equipped in that device.
Project Aria supports a variety of sensors that gather the sort of data that AR glasses will need to capture. These include a front-facing RGB camera, 2 side-facing monochrome cameras, and dual IMUs, which each contain an accelerometer and a gyroscope. This combination of sensors allows us to both observe the environment and track the position of the glasses, the wearer's hands, and objects within the scene. In this example, we can see the trajectory of the device being calculated from both the camera and the IMUs as the glasses wearer interacts in an apartment setting.
In order to work at all, augmented reality has to completely map the world around the user. And as you can see in Project Aria, it's able to do that with enormous fidelity, tracking the user's position and orientation in space at all times, and to keep track of everything within their field of view. So this is the baseline. That is in a sense, and this again is for the spectacle version of augmented reality. So the display version, that sort of device represents table stakes. So all of these devices will do this. And of course, if you're using Pokemon Go, the camera is essential because the camera and the GPS are situating the player in time and space within the game itself. So we have to confront the fact that augmented reality, at least as it's being presented to us, is creating what I call the omnidirectional panopticon. It is a technology of surveillance, and it surveys in every direction, because those cameras aren't just pointed out. Those cameras are pointed in. They're tracking the gaze direction and the foveal center of the users. Now, there are arguments for tracking the foveal center in order to render rendering more efficient, that you would only render things that the user is looking at or more or less closely at. And fair enough, but the gaze is privileged information, because we may say one thing about the things that attract or repel us in the world, and then we may do something else. In other words, the gaze reveals all sorts of information about ourselves that we would rather hide. And so when you're talking about the surveillance capacity of augmented reality, again, that surveillance capacity works both outward on the world and inward upon the participant. And so this is something we have to consider incredibly carefully as we get these devices and as these devices achieve scale. And it brings up the three basic questions. And these questions need to be asked of any technology, but really they need to be asked very specifically of augmented reality technology. First, where is all of this data going that's being gathered? How much of it is being pointed up to the cloud? Why is it being pointed up to the cloud? When is it being pointed up to the cloud? All of that tends to be very opaque, and we need as much transparency in these systems by design as can be afforded. All right, next, how is that data being used? We know that social media companies, and Facebook in particular, or is it Meta? No, I think we're going to talk about Facebook because it's the social media arm. We know that the surveillance data that they gather simply by using your app and tracking you wherever you go in your browser is then used to trim your feed so that your feed amplifies the things that it knows that you're interested in order to keep you on your feed for as long as possible. And so it's possible to build in these feedbacks into these systems. In other words, the data that the system has collected is being used to hack you, to basically to change your behavior. And again, this is something that not only do we need transparency on, but we perhaps need regulation to prevent from happening. And then finally, who owns all of that data? If I am the originator of all of that data on this device in this place, why would anyone else actually have rights to that data? Yes, they may have it insofar as they're using it to helpfully augment my environment, but don't they then have to throw it away at that point? Are they allowed to retain it? Why are they allowed to retain it? What are they doing with it? Now, these are questions that we can, again, usefully ask of all technologies these days, but we need to ask them before we actually put a set of augmented reality spectacles on, because of the immense capacity of augmented reality to be able to change our behavior in space. All right, so those are all the sort of dilemmas. These are the things we need to think about when we approach augmented reality. But assuming we can navigate those, and that is by no means a short, but assuming that we can navigate those, we actually now start to get to the use case. Why would we want to use augmented reality? And here I'm going to show you the engine of a 2020 Mercedes. Not a lot to see there, is it? Because basically everything about the engine has been covered by a thick plastic panel, which presents something that allows you to fill the antifreeze, something that allows you to fill the oil, and something that allows you to fill the windshield wiper fluid. That's basically it. There are, quote unquote, no user serviceable parts inside. So they cover it with plastic in some sense to sort of take it out of mind, but it also takes a very complex machine and now makes that machine completely opaque. This is a symbol of the way all of technology is now so neatly packaged that basically it hides itself from view. And so what if you're out and about, perhaps even outside of cell signal range, you're driving between cities and the car dies? What do you do? How do you fix it? How do you even know how you might fix it? And we all go, well, these cars are very sophisticated these days. They have all these computers, It takes, you have to take it to the dealership to get it fixed. Well, that is in fact something that's imposed by the designer, right? That's a decision that Mercedes made. And augmented reality has a way of being able to alter that balance, because it should be possible for me with my spectacles to look upon any machine, no matter how complex, and get the information that I need, not just to understand the machine, but also to understand why the machine is not working, and maybe even how I can repair the machine, or at least get it working well enough. Now, this is a phenomenon that needs to be applied to the entirety of the world. We have spent 30 years now building the web into this enormous edifice of human information, of human resource, of helpfulness. But when we look out onto that world, we don't see any of that information. That information needs to coexist in real time with our experience of the world. We need to experience what I call digital depth. That digital depth allows us to then change our behavior in space. To come back to the original example of Pokemon Go in Peg Patterson Park on that day in July of 2016, all those people saw data in space and changed their behavior accordingly. That is the great promise. We live in a time where we know that we need to change our behaviors, not just individually, but culturally as well. And that we can do this not entirely, but certainly with the assistance of the digital depth that is offered by augmented reality. This is certainly my own focus. I spend a lot of time thinking about how to take all of the data that we know about the world and then presenting that meaningfully to people so that they can make the best possible decisions with that information at hand. That may not have to come through spectacles, because remember, we're talking about locative data in space. It could be showing up meaningfully on my watch. It could be showing up meaningfully on my smartphone. It could be showing meaningfully on my tablet. It doesn't really matter. It just matters that the data is there, that we have a way of bringing it in, and then that becomes a basis for us to be able to make decisions. So you can see the two faces here. Yes, this is an insane technology of surveillance. This is an insane technology that perhaps could be used as a tool of control, but it also offers a kind of liberation around data that we need to see our way through to the future. That's it. Thank you very much.